my presentation. Today we are talking about the NaviChair, the new navigation interface we use for navigating through the virtual environments. My topics are about, first I have an introduction about the whole concept of navigation and their problems. Then I have we have a look over the background works. Then we describe the NaviChair interface. In the next section, I talk how we manage an experiment to measure it. And finally, I come with the results and the interpretation. And the final section is the future works and conclusions. Virtual reality. Maybe the first thing we know about virtual reality is that virtual reality feels so real. Like this.
And then there's a fucking face. Staring at the skeleton. Oh shit!
Why virtual reality is so real? Why you really feel yourself inside the environment? That might be because something we called it illusion of self motion or erection. When in virtual reality you see yourself, watch yourself while moving inside the environment, it really gives you the illusion that you are moving and it feels so real. This illusion of self-motion is called vection, which is our research on. Usually from around about 100 years ago, human discovered the vection. Usually lots of people has this experience. For example, they sitting in a train and wait for train to leave the SkyTrain station. The adjacent trains leave the station before their train, and when you watch the adjacent train, you have this feeling in your guts that, oh my god, am I moving? Usually this feeling called vection, and we use this feeling in the virtual reality so much. Usually in virtual reality we try to use big screens or vast field of views to give this feeling to the people who are in the environment to feel themselves like moving. But there are some issues. For example, the first issue is the vection intensity. Usually the vection intensity is not as much as you want. Usually, because to raise the vection intensity, you need to make the movement fast, use the different big elements on the screen should be moved. But there are other problems. For example, usually the vection will not be started immediately after watching yourself while moving. It takes a couple of seconds or sometimes half a minute to really feel like you're moving. And maybe the biggest problem is the motion sickness. When you try to, for example, raise the vection intensity and you will have faster movement, everything on the screen start to move. Usually people have this feeling. Why the motion sickness happens? It is because we have in our inner ears some vestibular sensors which are responsible for measuring the gravity force on our body to help us hold our balance. They also can feel the acceleration force of our body. So when you see yourself while moving, your eyes tell your brain that you're moving, but your ears don't have any acceleration force, so your ears tell your brain that you're not moving. So if you try to give lots of motion cues, it usually makes you sick and vection feeling happens. So it is hard to raise the vection intensity and at the same time control the motion sickness. To help human body to have a better vector intensity, there are lots of research who try to change the, for example, joystick or other common navigation use. They try to use new interfaces which give you your body the feeling like you're moving, like these walking interfaces which you can see. Actually, these are not so much good because even, for example, your feet have this feeling like you're walking, but your head is still at the same place and you don't have the acceleration force over your head. So these idols usually cannot work so much. There are some other idols which move your body to give your vestibular sensors some feelings, and you feel like you're really moving. They try to help you to have a better feeling of movements. We try to invent or use a new interface to see can we motivate the human vestibular sensors with not such a big, expensive idol. So we went to a normal chair called swapper chair. You can see usually swapper chair as we work used in different places like office and other places. Swapper chair has the different degrees of freedom. You can move your body to front, back, left, right, or rotate. It's very easy because it has a spring which helps you to do that. We just added a positional tracker sensor to it to measure the exact position of the swapper chair in each moment, and we designed our NaviChair using this swapper chair. Then we designed an experiment to measure does our swapper chair can be as good as joystick or other navigation to give or the players a better feeling like moving. We designed this experiment. In this experiment you can see 3 different conditions. In the first condition movie, people just sit on a normal chair and see and watch themselves while navigating in an environment. Is something like a movie, they don't need to do anything. In the second condition, they use a joystick to navigate inside the environment, and for the final one, they use this NaviChair. Using this NaviChair exactly feels like you're sitting on a joystick and you need to push your hip to front, back, and rotate to different directions. We use different paths to linear paths. The users just need to move forward, they need to rotate, or they need to do both of them at the same time to have more control over it and in the same and different directions. We asked 18 participants to participate in our experiment, 9 males and 9 females. Their age was between 20 and 40, and all of them were SAP students. The experiment happened here in this environment, a big environment with lots of visual cues. When you start moving, these visual cues give you the feeling like all environment moves, and it can increase your vector feeling. And the experiment steps are these ones. The first phase is the vector familiarization phase. We just move them through a big path to help them feel the vector and be familiar with that. Then for each of our devices, they had a device practice phase, then the main experiment, and finally they needed to fill an online questionnaire to rate their experience. And then after the whole experiment, we had a final interview to ask them about their weakness or strengths or in the project. The result, as you can see, the results are not as good as we wanted. It seems that even when you use a new interface which helps you to move around the environment, the control is a real problem. You need to, the control should be so intuitive, it should be so easy. Yeah, the joystick and NaviChair help people to feel a bit more vection, but not so much because they had challenges with controlling it, and they had not enough time to be used to it. So as you can see, even they felt a little bit more vection, but the latency of vection happening is almost the same, and the motion sickness it could be increased by using this stuff. Maybe we hypothesize that the joystick would be is more than movie, because in movie you feel yourself in a constant speed at it, pretty smooth, but in joystick, because you cannot control joystick, you have more up and down, raise your speed, lower your speed, which gives you a more motion sickness. And with NaviChair, because you need to move your body and it's hard to control your smooth movement, it can make you more sick. So we think about how can we improve our NaviChair for our next experiments and come up with a new interface. There are three ideas we have. First of all, we know that the most important thing about the NaviChair is that it should be, its control should be easier. We need to modify the smooth function of NaviChair or participant to control it better in our speed, in the SPB1. And then they need to find the path easier. They should not be confused for finding the path. Usually they have this, but they just try to follow the avatar in the environment, and that was somehow confused them. And finally, to reduce the motion sickness, we need to use the dissolve screen to each other and not sharp cutting, because 3 of our 18 participants, because of their motion sickness problem, we just had forced to stop the experiment for them. And yeah, this would be our next measure in this experiment. Is there any question?
A couple that are, this is a very interesting topic. I have students that play around with it in one of my courses as well. I'm almost wondering whether instead of using a joystick, if a mouse with the forward and backwards wheel on it might be easier to control than the joystick. So I was wondered whether you tried that or experimented with that in the past, or other experiments had done that.
Usually, using joystick is really interesting because almost in every game contest around the world, usually the joystick and keyboard are known as the easiest controllable devices, and because of this reason, usually they are prohibited in the world campaign between gamers. Because using them is really fast and those really help people, but unfortunately for navigating through environment, because if you just sit there stable and just move your hand, it cannot give you vestibular sensor inside your ears, the feeling like you're moving, so it still makes you sick. So for vection intensity or vection latency or motion sickness could not be improved so much with this stuff. You actually need to move your body to different ways to give the sensors the motion cues.
The other question I had was, I wonder whether anyone's tried combining 3D with vection to see whether that improves the, or decreases the amount of motion sickness.
Which type of 3Ds?
Three-dimensional. So that you've got usually, when something's coming at you, it's coming from 2 different angles. So when we see things, it's real 3D, right?
Yeah, maybe it was part of mine. Maybe I need to make it more clear. I show our experiment here. We use this Oculus Rift for our experiment, and people use this 3D head-mounted display, so they had a 3D view.
So they are getting that.
Yeah, I just forgot to mention because
Okay.
usually because of this image we know that the experiment was 3D, but yeah, you mentioned that yeah, we actually had a really 3D exactly the Oculus Rift, so they had the real feeling of
Okay.
it. And in this screen is just for the experimenter to see what are they watching now, but the users have a total field of view to see everywhere inside their head-mounted display.
Okay. So are you tracking their heads when they're using that at all? You know, in terms of seeing how they're moving their head, and if there's any correlation with when they start feeling nauseous.
Usually, the Oculus Rift, this head-mounted display, they have gyroscope sensors inside them. So when they rotate their head to different direction, it just rotates the view, so they have full view, the smooth view. It has about 75 frames per second. So it's really a smooth view for the experiment, but it does not have the transformation sensor. So when you move your head, it cannot detect, but when you rotate your head to different direction, it can detect. So usually Oculus Rift has some the outside sensors which can detect it, but we did not use that because in our experiment they did not have enough time to use this. They just need to follow the avatar, this avatar in this environment with a fast, with a speed about 5 meters per second. So yeah, we did not need to use this type of outside transform sensor. Yeah. Next one.
Sorry, what's your major?
Virtual reality.
No,
My
which
background?
department are you?
Excuse me.
Which department are you?
SIAT, School of Interactive Arts and Technology.
Thank you.
Yeah, these are all these interfaces are some interfaces to make easier the interaction between human and computers, and SIAT is a school for designing and using these new interfaces. Yeah, for example, another interesting interface is the emotive EEG, which is some sort of bearing control sensor. You just put it like a headphone on your head, and then you can focus to different stuff, and you can move your player through the game. But for example, when you're thinking about left, your player goes to left and right, you just can have a brain control of it. Yeah, all of these stuffs are researching in SIAT to design a better technologies.
All sorts of uses for it. I expect 20 years from now, people won't be using a computer. They'll be just in the air.
Exactly. Yeah, that's for very good.
Great. Thank you.